So we're here at the Linaro Connect. So who are you?
I'm Daniel Lezcano. I'm part of the power management team, and I'm working on all the CPU idle stuff.
So CPU idle.
Yeah.
That means that you want the ARM processor to be off most of the time, or what?
Yeah, this is part of the CPU idle optimization, but actually what we have is in the idle routine we try to power down the different peripherals. So the multiplication of the different SoCs make the multiplication also of the drivers, and with different implementation inside. So we are trying to consolidate all these drivers by changing the way they are managing the different peripherals and move that into the PM runtime. And so we expect to have the CPU idle driver to be a bit empty, if I can say. So very, very simplified. And then that will be up to PM runtime with the generic power domain to attach to a CPU idle state and prevent and the governor will prevent entering this state if the power domain is in usage. So we don't have to take care of power down or power domain if it's in use or not in CPU idle driver, because it will be up to the governor to handle that.
So is this super advanced stuff? What is it?
Advanced? Yes and no. There is a lot of study and investigation around the behavior of the stock, with the interrupts, and all the stock will wake up. And so we have to investigate these wake-up sources and try to optimize these wake-up sources. And also with the increasing complexity of the SoC, we have multi-core and multi-package SoC, and the constraint here is you cannot power down a single core. You have to power down both cores. So we have to create some kind of algorithm to synchronize both CPU to enter the idle state. And this algorithm could be different depending on the hardware. So typically we have a Tigra or OMAP4 using coupled C states, and other SoC using a simple landman standing algorithm. So what's new is the package idle algorithm, and we have to try to improve the scheduling of the task to have both CPU, increase the probability to have both CPU entering in idle at the same time. So otherwise the CPU idle driver won't be able to shut down the entire cluster. It will just put one core in wait for interrupt and clock gating, and we don't have much gain of power saving. So the main objective is to optimize the package idle stuff and so be able to enter in DP idle state.
So you're at Linaro, right? So why is Linaro working on this? What is it for?
Oh, Linaro is working on this because the different SoC vendors have their own CPU idle implementation, and they are working out of tree with a single kernel version, and they are backporting everything from upstream to this version. So it's that increased the cost of maintenance for the kernel. So the part of my job is try to consolidate the CPU idle drivers and find a way to have a single ARM CPU idle driver to force the next developers to use the same scheme for CPU idle. So prevent duplication of code and complexity. So that's useful for the SoC vendors to reduce the cost of maintenance of their driver.
So what you're saying is the CPU idle, is it saving power on all ARM processors, no matter which ARM processor? Is that what you're trying to do?
Yeah. Yeah, we try to find the common places we can group together into a generic ARM driver, and move the ARM-specific function to a very simple function we can handle easily in the ARC architecture-dependent code.
So you have a colleague over there. He's from Italy.
Lorenzo.
Is he also Linaro?
No, it's ARM.
ARM.
Yeah.
So what is he doing and what are you doing? What is different?
Oh, we are working more or less. We are working together on this topic, and also is working on a different SoC, which is the V Express for the big little architecture. So it's also investigating. It's complementary with the work I'm doing right now. So mostly we're working together.
So when people talk about ARM, they talk about low power. So it's kind of like the core of what ARM is all about, what you're doing. It's the key between software and the hardware to make sure that low power works, or?
Part of it. So what happened is the CPU driver is in the idle path. So every SoC vendor find this place useful to put all the power management stuff. So saying, okay, we are in CPU idle, that means we are idle, so we can do all the power management stuff. And that added a lot of complexity. And the power management should be, there is the CPU, and what we're trying to do is to have CPU idle to handle CPU, and the PM runtime to run the peripherals power management. So split both instead of grouping everything in group inside the CPU idle driver.
Is it for all ARM processors, or only for 64-bit, or for current, or what is it for?
CPU idle?
Is it all? Is it going to be for Linux on every ARM CPU, old and new and future, or is it 64-bit?
This is what we are trying to do.
Trying to what?
Well, this is what we are trying to do, is to consolidate, to have the most generic driver we can have.
Do you have to look at what comes in the future to make it work?
Yes,
so right. You have to look at 64-bit.
Yeah.
And it has to be backwards compatible.
Yeah, but for the next version that will be easier, because we have a proposal which is PSCI, and the PSCI will define, give a description of the CPU idle behavior and the driver, so we can build the module directly from the PSCI. So I don't think in the future for PSCI-based board that will be a problem. But for all the other boards not using PSCI, that includes old code and maybe next SoC, we have to take care of that and try to reduce the driver complexity.
Do you have to invent new ideas to make this work, or you just is it just straight ahead? It makes sense what to do. Everybody knows what needs to be done.
No. Everybody no. It's not. Sometimes we have to bring new ideas, but most of the work is understand the behavior of the hardware, which is very different across the SoC, and this is where is the difficulty, because we have to understand the hardware behavior to fit the need of the CPU idle.
All right. So, is it going to be interesting? What's going to happen in the next few weeks, months, years?
Yeah, in the next weeks, I will propose a prototype for a single ARM driver. So that will be the first stone of the edifice of a new code for ARM driver.
Unified firmware for all ARM Linux? What does it mean?
That means a driver, a simple ARM driver, and where we plan to move, where is possible, the code inside the SoC specific driver, move this code from this place to the ARM generic driver.
All right. So thanks for your talk.